Let's do a couple of examples here. Actually, we're going to do several examples, and I urge you, don't just watch one or two and quit. Stay with me here. So let's think about this one, and if you want to print off this note sheet, you can. I'm going to try to actually blow this up here so that you can see the graph a little better. So we're doing this first one, y equals negative 2 to the x, and then we're going to answer each of those questions that's up in the box. I just have more room on my paper to write it like this. All right, if I wanted to graph this equation, first of all, we just graphed y equals 2 to the x. And I'm going to put this on here in pencil. We saw that it kind of looked something like this. Okay, there's y equals 2 to the x. Let's graph y equals negative 2 to the x. And I bet some of you can already guess what's going to happen to this graph because you know what happens whenever you put a negative in front of an equation. I'm going to graph this one by making a table of values. So I'm going to think and be strategic about the numbers that I put in for x in order so that I get good outputs. So since this is just x up here by itself, I'm going to start by putting in 0. So I'm going to have 2 to the 0 power, but then I'm going to make that negative. 2 to the 0 power is 1, and then it's going to become negative 1. Okay, let's try 1. 2 to the first power is 2, but since we have a negative in front, the output is negative 2. Let's try 2. 2 to the second power is 4, but because there's a negative in front, it's negative 4. Let's try negative 1. 2 to the negative 1 power is 1/2, but because there's a negative in front of it, it's negative 1/2. And we can see then at negative 2, I'd get negative 1/4. So I'm graphing 0, negative 1, 1, negative 2, 2, negative 4, and so on, so it looks something like this. So what happened here? This graph looks the exact same, except for this has reflected over the line y equals x. So putting a negative in the front makes this a reflection. Let's then try to describe here. Let's think about, oh, by the way, this is still an exponential growth problem because of the 2 right here. This negative has no effect on whether it's growth or decay. So since this is a number bigger than 1, even though this is going down, I have to think about what its reflection would look like. Its reflection looks like a growth, so this is exponential growth. Let's think about the domain of this one. The domain, the values that I can put in for x would be negative infinity to infinity. The range this time, the smallest y value is negative infinity, and the biggest y value that I could have is 0. So the range goes from negative infinity to 0. Let's think about the asymptote. The asymptote is the line that this graph approaches but never touches, and it's going to have the same asymptote as its reflection. The asymptote for this, an asymptote is an equation, is at y equals 0. Let's think about the end behaviors. This end, x is approaching negative infinity as y approaches 0. This end, x is approaching infinity as y approaches negative infinity. All right, let's do another graph. Let's go do the second one on here. That's y equals 2 to the x plus 5 power. Y equals 2 to the x plus 5. I'm going to graph this one by making a table of values again. But this time I want to be strategic about the numbers that I try for x. Typically I start with 0, but I want to start with 0 this time because if I put 0 in for x, this is going to end up being 5. and I'll have 2 to the 5th power, which is 32. That's too tall for my graph. So I usually pick 0 because 2 to the 0 power is 1, and that's an easy thing to graph. So this time I want to pick something for x that actually makes this be 0 on the top. And the thing that would make that 0 is if I picked -5 for x. Because 2 to the -5 plus 5 is 2 to the 0, which is 1. Now you may want to go use Desmos or the graphing calculator app on your Chromebook to find these tables, and that's totally fine with me. I would probably use a graphing calculator app if I had one, or the TI-84. So now I want to pick numbers that are close to -5. So I'm going to pick something bigger like -4 and -3, and something smaller like -6 and -7. So I'm going to try -4. -4 plus 5 is 1, and 2 to the 1st is 2. -3 plus 5 is 2, and 2 squared is 4. If I pick -6, it's going to be 2 to the -1 power, which is 1/2. And so then the next one would be 1/4. So this one's going to look like this. I'm going to go over to -5 and up 1 for my first point. I'm going to go over to -4, 2, -3, 4. And then these are going to become fractions. So let's take a look at this one. How is this one different from 2 to the x? Well, it looks like it's been scooted over to the left 5 units. So putting the plus 5 with the x moves it to the left 5 units. How's that going to change things? The domain isn't going to change. The domain is still going to be -infinity to infinity. And the range is still going to be smallest y value is 0. Biggest y value is infinity. The asymptote is the same. This thing still isn't going to cross y equals x, so the asymptote is y equals 0. And then the end behavior, as x approaches -infinity, y approaches 0. And as x approaches infinity, y approaches infinity. You could find, we talked about that with polynomial functions. We talked about end behaviors. You can also watch on Delta Math, though, they'll have a little video about the end behaviors and how to find this whenever you actually do your homework. This is probably going to be one of the tougher homeworks just because it involves so many different things.